Let's take a look at number 25. Although part A asks you to start to find the x-coordinates where there's a maximum, minimum, really we should start with part C. We want to actually graph this. Alright, we're going to graph it, and then we're going to be able to answer the other questions after we graph it. So we're going to look at this table. First row here, I guess second row, f of x tells us the graph's going to be positive or above the y-axis from -2 to -1, above it from -1 to 0. It also gives us a point here at -1, 2, gives us a point at 0, 1, 1, 0, 2, -1. So those are all points that we can plot on our graph when we're ready to sketch it. Then we also want to go ahead and make some number lines. We're going to make a number line for the first derivative and the second derivative. You don't necessarily need to, it's kind of all set up there, but if it helps you to look at it this way, feel free to draw your derivative number lines. So for our first derivative, it's 0 at -1, undefined at 0. It is 0 at 1, and it is undefined at 2. So we have our critical values. These are all where the derivative is 0 or undefined. So these are critical values. That's where we could have local mins or local maxes. Now we want to look at what happens to the derivative in between these values. So the derivative is positive from -2 to -1. So it's going to be positive in here. Then negative, 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 and positive. So from this, we can figure out that we're going to have a local maximum at x equals -1 and a local minimum at x equals 2. Then we want to go ahead and take a look at our second derivative. So our second derivative, we're looking at the same values here, -1, 0, 1, and 2. Here the second derivative is 0, undefined, 0, and undefined. If you want to fill in the spaces in between with the information given to us, it's going to be second derivative is negative or concave down for f, negative, positive, negative, negative. So remember, when the second derivative changes from negative to positive or positive to negative, we have an inflection point. So there are two inflection points for this one, at 0 and at 1. Now we can take that information from these number lines and sketch a graph, along with some more information we had up top. So let's look back up here. It gave us some points. We have a point at -1, 2. We have a point at 0, 1 and 1, 0, as well as 2, -1. So those points were given to us, and we can see here that we're going to have a maximum at -1, so that looks about right, because we're increasing and then decreasing, so we're going to have a maximum here. We're going to have a point over here that's a little bit lower. And then it's decreasing from -1 to 0, decreasing from 0 to 1, decreasing from 1 to 2, but then it increases. So that means we're going to have a minimum right here at 2. So we're going to have a point above above -1 when x is 3. Notice though that we have these intervals. It says that from 2 to 3, f of x is going to be negative. So we want to make sure we don't put our point for 3 like up here, because it's going to be negative that whole time. We could put it at 0 if we want, or maybe we'll just go ahead and put it a little bit lower, but it can't be above there. Also, it says that from -2 to -1, f of x is positive, so we have a positive y value. So we're not going to put a value below the x-axis over here. We could put it on the x-axis or above it. I'm just going to go ahead and put one above there. Now we need to fill in the curves, connect the dots, using the concavity. So, things to keep in mind, we have undefined derivative at 0 and 2. That means we could have sharp turns or vertical tangent lines at those points. So we want to make sure that happens. Let's go ahead and take a look. Concave down from -2 to -1. So concave down from here to here. Then it's concave down from -1 to 0. Concave up from 0 to 1. Concave down from 1 to 2. And then concave down from 2 to 3. So we do end up with our sharp turn here where the derivative is undefined, and a vertical tangent line here where the derivative was undefined. So that makes sense from what we're seeing in our table here. So this is our graph for part C. Now we want to go back to parts A and B and answer our questions. Part A says find the x-coordinates of each point at which f attains an absolute maximum or an absolute minimum. So now that we have that graph, we can tell that the absolute max is going to be at x equals -1. Right, there are no points on the graph that are going to be higher than that. Even if yours isn't exactly like mine, that's going to be the absolute maximum. And the absolute minimum is going to be at x equals 2. Now, it just so happened our local min and local max ended up being the absolutes. That's not always the case, but here it did end up that way. So just because we found them on here, these are technically local. We're finding local max and a local min that end up being our absolute max from what we see in our graph. Then for part B, find the x-coordinate of each inflection point on the graph. Well, x-coordinate, we have them at 0 and x equals 1. Those are our inflection points because that's where the second derivative changes from positive to negative or negative to positive.